Welcome to this OST2 lecture about the generation of the endorsement key using eSAPI and the TPM2 TSS. We already learned about the different properties of the endorsement hierarchy and the endorsement key. Now we'll take a closer look how to generate the endorsement key using TCG templates and eSAPI. The Trusted Computing Group provides two main types of templates for an AK. They are generally referred as low range and high range. And this refers to where these templates are stored on a TPM in its NVRAM. The low range are the initial TCG templates for an AK. The good thing about these templates are that they are backward compatible and they should work for any TPM 2.0. Usually they come as two variants, RSA 2048-bit and ECC with 256-bit curve. Also, the low range template A and B are using TPM policy. This means that we cannot satisfy the authorization required for a primary endorsement key by just using a password authorization, or HMAC. We'll look on how to satisfy such a policy as a first step toward learning something about TPM 2.0 policy. And we have dedicated lectures to talk about TPM enhanced authorization and TPM policy crafting. In the high range, we have more updated and modern key templates. Again, we have RSA 2048 bit size. We have the ECC P256, but we also have P384 and P521, alongside the SM2 variant of P256. The benefit of using the high range of TCG templates for an AK is that they can be satisfied by either a policy or EK password. If a TPM vendor decides to use a non-default EK templates, such that are not defined by the TCG, and yet these are the templates for that TPM model and that TPM variant, then they have to be provided in the non-volatile memory of the TPM, so the user or the administrator of the system can walk the chain of trust using the EK certificate, using the EK generated by this non-default template, and using the intermediate certificates of the vendor to establish a chain of trust to verify the authenticity of the TPM. In summary, we either use the TCG templates that are defined in the TCG specifications, or we use the templates available in the NVRAM of the TPM. And in most situations, this would be the same. So we don't have to look up some specifications, we can just read the template from the NVRAM locations. The implementation approach is up to the developer. Here is an example of low-range template L2. This is the ECC P256 template. The L1 is for RSA 2048-bit. What I would like to focus here is the object attributes. Naturally, we have fixed TPM and fixed parent. We talked briefly about these flags in TC1101. This means that our TPM key cannot be duplicated on another TPM. Then we continue forward and we see user without is set to 0. This means that we cannot satisfy the authorization for this key. We cannot use that key by just providing a password. And then we have admin with policy flag set to 1. This means that we need to provide a policy digest to satisfy this policy. And if we go a bit further, we see out policy being set to 32 bytes. And here's the policy digest. This line here saying TPM2 underscore policy secret TPM endorsement hierarchy as an argument is more of a hint, a reference to how to satisfy this policy when wanting to use EK generated with this template. So this is not really fitted in the buffer, but it's just a hint because it often comes up as a question to developers when trying to use the TPM EK for the first time. And of course, below we have the parameters for the key, which are pretty standard regardless if we're creating a primary key under the endorsement hierarchy or the primary hierarchy. We have the curve here selected, P256, and we have the size of the different ECC points. Now, why we have chosen this template? Because based on my industry experience, the ECC keys are more portable in the sense that we can use them on IoT systems, we can use them on edge systems, and they're great also from performance perspective for even high-end systems like data center servers and high-end workstations, company laptops, and so on. Now, why we chose the lower range of TCG templates is because of backward compatibility. We want to give you knowledge and know-how about something that would use across TPMs. As you know, there are multiple vendors and each vendor has more than one model. Important differences when generating the EK compared to our first labs is that you need to make sure to set the hierarchy to endorsement rather than owner. Also make sure to clear the user without flag, because the TCG template, the lower TCG template, require a policy and not password authorization, and then make sure to set the admin with policy flag. Also, in order for the policy to work, we need to provide the policy digest in the out policy area. When working with the endorsement hierarchy, it is also important to not forget to set the authorization to the hierarchy itself, and this is done using the ISIS_tier_set_out API. The default authorization is empty. If you have changed that, make sure to enter the new authorization value. Once these parameters are set, we can just call ISIS_create_primary as usual. Generating child keys would require the use of the endorsement key to wrap the private material of the child key. And to use the EK following a TCG template, from the lower range, we need to satisfy the policy. We will need to satisfy the EK policy twice before we are able to use the child key. And if you remember when discussing the ISAPI API for creating a primary key, creating a child key, and loading it, the creation of the primary key and the load procedure in the TPM happens at once when we call ISIS_create_primary. But with the child keys, we have to create the key and then load it. And because the creation of the key involves the EK wrapping and protecting the child key, we need to satisfy the EK policy once. And then when we want to load the child key, we fetch encrypted private material. So we need to authorize again the primary EK to unwrap the private material of the child key and then perform the TPM load operations using ISIS load. So how to satisfy the EK policy for TCG template L-2? We already learned how to start TPM sessions in a previous lecture in this course using ISAPI. So far we've created TPM sessions of HMAC type. Now we'll create a TPM session of policy type. We need to make sure to set the hash algorithm to SHA-256 because this is the algorithm used in the TCG template when crafting the TPM2 policy. And of course, we can enable parameter encryption. As usual, just make sure to set the right session attributes on this policy session that we just created. Now, generating a policy to prove knowledge of the endorsement hierarchy authorization requires us to first set the password to the endorsement hierarchy as mentioned, and if you've changed the out, make sure you set the new value. And then we create a policy secret on the endorsement hierarchy. This will result in the same policy digest that will match to the one we put at creation time in our primary endorsement key. Now, here are some reminders about endorsement hierarchy, EK and EK policy. When you're doing the labs, I think these pointers will be useful. Make sure to set the hierarchy out. Here's an example how you can do that. We just set an empty out value and then we use it with a tr set out. Now, the generation and loading of the child keys would require EK policy. We talked about the fact that we need to satisfy the EK policy twice, first at creation and then at loading. Once we have our endorsement child key created and loaded, we just have to provide the authorization for that child key, which means that if we've set a password authorization and user without value, then this would work without having to satisfy the policy again. The policy is related only to the EK, which is the primary key under the endorsement hierarchy when we follow the TCG specification. Because this is the first very complex topic we're covering in this course, and is first of many, there could be a bit of frustration when trying to solve the labs. Just keep in mind that all of the information needed to solve the labs is present in the lectures. And if you have any questions, do not hesitate to reach out and ask. This is how we learn. If that doesn't help you get to the end solution, then check out the solutions we provide in our code repo for this course. Here is the link. We have the template, ISAPI application, and solutions for all labs available in GitLab. In case you have more questions, feel free to reach out in the OST2 discussion boards after each lecture.